What we study is the chemistry of the Earth and to some degree also the chemistry of the solar system. So we are interested in the chemical processes that drive the large-scale environment of the Earth and the solar system. And we're looking at the cycling of components in the Earth and in the atmosphere, the exchange of these components between the biosphere, so for example the plants, but also the living biosphere in the oceans and the atmosphere. And we want to know how this affects, say, the quality of the air that we are also breathing, and also how it may change the climate. What we really like to do is to go out and study the natural environment. And this is becoming more and more difficult because the influence of man on the atmosphere has become so tremendous that it is very difficult to go to a place on Earth where you really find the natural background atmosphere. But this is what we're trying to do, so we're using ships and also newly developed aircraft that can really fly over very long distances and go out in these regions to see how they respond to certain changes in the atmosphere, and then contrast this with some of the things that we have learned in the more polluted air, like in Europe or in the United States. Well, actually I started my scientific career in this institute. I was a PhD student here with the person who I was later allowed to succeed here, Paul Crutzen. And so I did my PhD here because I was very interested in doing science based on a more practical type of work that I was doing before that. I was working for a company doing atmospheric measurements, and this stimulated me to get more involved in the science of it. And then I did my PhD here, then I went back to the Netherlands. I worked in Wageningen and in Utrecht for a number of years. And then I was invited to take on the position that I currently have in the year 2000. What I am personally most interested in is how the atmosphere is regulating its cleaning capacity. So if we are emitting or if we are producing exhaust with industry or by cars, these products of activity must be removed from the atmosphere because many of them are poisonous. They have to be removed and they are being oxidized and then rain out, so precipitation removes the product of these components. And what I'm investigating is to what extent the atmosphere can handle all of the pollution that is being pumped into it and then being removed, and also see if there is a point where the atmosphere can no longer handle the large amount of pollution that is being emitted. So this is a very practical question. First of all, we need to understand how the atmosphere works, how the chemical processes in the atmosphere work, and secondly, to what degree does humankind change these processes, maybe up to a point where things can even become dangerous. So that's the main question that I'm pursuing. There are three things we do, and they belong together. First of all, if you look at chemical processes, you need to study the chemical reactions in the laboratory. So we are looking at reactions and study, how these reactions are, how they proceed in the laboratory. So this is real lab work. Then we go out, we have a number of instruments that we also use in the lab, but also additional ones, and we take measurements in the atmosphere. And then the third component is that we develop computer models, and these computer models, they integrate meteorological processes with atmospheric chemical processes. So that means that a molecule that's introduced in the atmosphere is being moved through the atmosphere by the meteorology, by the airflow. So these models must be able to describe the airflow, and on top of that we look at the chemical reactions and the interactions with clouds and the interactions with particles, etc. The most recent, I would say, discovery that we made is that the atmosphere is actually more stable than we thought. Because there is a lot of pollution, as I indicated earlier, being emitted into the atmosphere, And what we did is we said, okay, let's start with looking at the natural environment where there's a lot of natural pollution being introduced in the atmosphere. So we went to the Amazon. And in the Amazon there is a lot of forest that emits an enormous amount of hydrocarbons into the atmosphere. And why exactly the forest produces so many hydrocarbons we don't really know. But anyway, we went to the forest and we found that there is a really very efficient recycling mechanism that helps clean the atmosphere. So from nature we learned how the atmosphere can clean itself by making use of certain chemical pathways. And this has become a research area, a very hot research area that people are now looking at in laboratories and also in many other groups over the world, not only in the Amazon but also in other forests, and now also more also in the natural environment that is very close to the cities, etc. Well, the memorable moments here are mostly related to when we go out, either to the Amazon or also to India or to the Indian Ocean or remote places where you meet new and interesting people and also where you do interesting scientific discoveries. Well, that's what drives us, you know. Like I said, we go out and we go and measure in places where nobody else has been before. So it is, what drives us is try to discover something new. So yeah, you are discovering molecules or processes that may not even have a name yet, or that have a dimension that was totally unexpected. And this is what we are looking for. This is our business. This is our motivation.